Okay, let's talk about circles. Let us look at this beautiful image right here. It is round, right? And whenever you see a round figure, you're so tempted to draw a smiley face. There you go. Okay. So, what about circles? Well, we just said that it's round, right? So, a circle is pretty much round. What else do we notice about this circle? Or a circle in general? Well, it's smooth. No points or edges. And what else? Okay. You might be wondering what really is the definition of a circle. Well, it is a round figure with this boundary that I'm going to highlight. This solid line is what you called the circumference. And it's basically the perimeter of a circle. And we'll go over that later. But there are these points that you really can't see, but there are points on the circumference, and then they are joined, these points on the circumference are joined with this point in the center of the circle, and if I connect those points like so, then they are equidistant. The points on the circumference are equidistant from the fixed point or the vertex, or in other words, the center of the circle, and that's what makes the circle. Okay. Now look at that. We got a smiley face and it has a nose, so that's wonderful. Now, you have heard of the definition or of radius and diameter probably at least once in your life. Now, looking at this, you're probably wondering, oh my goodness, there's actually more to circles. Yes, this is high school geometry, so you're advancing your knowledge with some basic stuff to more advanced stuff. So here we go. Introduction to circles. We have some things to fill out, and we're going to start with the radius. A radius is a segment, and remember, a segment looks like this picture I just drew before recording this video. This is a segment. Now, a segment is a line with two endpoints. Here is an endpoint, here is an endpoint, and that means that it stops going from both sides, or on both sides it has a fixed point. It doesn't extend further and further, okay? So, a radius is a segment from center to a point on the circumference of a circle. And we have to list all of the radii, and radii is just plural for radius, okay? So we need to start from the center. This is the center. And it has to have a point on the circumference, so here is one right there. So from here, this is my center, and I draw the line, there's a point on the circumference. That is one example of radius. So we're going to say line segment CD as one of our radius. Okay, now what else? Well, let's just start from the center again, and then there's one over here. Okay, that is also an example of a radius, so this is going to be line segment EC. And then lastly, from center, there's a line, so we say line segment CF. Okay, so those are all the radii. Now we're going to move on to a chord. A chord is a line segment, so we're going to be finding something like this with two endpoints on the circle, or in other words, on the circumference. So here's our circle. We need to find 2 points on the circumference of the circle. Okay, so I see a chord over here because the two endpoints are on the circle. So I'm going to write line segment AB. Next thing, we got to find the diameter. So I'm going to call this, let's call this the diameter. Oh no, that is not the diameter. This is the chord. And then we need to call this the radius. this is also the radius, and this is also the radius, but I won't put that there for a reason, because that actually is the diameter. If I have a radius and a radius, two together, right, I actually form the diameter. It is a special chord that passes through the center of the circle. So here and here, this is what you call a chord, because there's 2 points on the circle, and it passes through the center, C. So that is my diameter, E. Ooh, that's not the color I want to use. Okay, so this is going to be EF, or segment EF. Next, we need to look at the definition of secant, and the secant is a line that intersects a circle in exactly 2 points. Okay, what does a line look like? It looks like this, right? You have a line with an arrow on one side and an arrow on the right side. That means that both sides are extending infinitely. They are going to keep on going. It is not stopping, unlike our segment, which does stop. Here, it's just moving and moving and moving on both sides. So we need to find something that has arrows and it intersects a circle in exactly 2 points. Okay, let's look at it. How about this? I'm going to leave this as an exercise for like 10 seconds, and then you're going to tell me which one is it on the circle, okay? All right, you got it. Yeah, that's right. You look at this line HJ, right? Because there's our arrow, and there's our arrow. So that means that this is our secant, because it is a line that intersects a circle in exactly 2 points. There's a point and there's a point. So we're going to write HJ, line HJ. Okay, let me label everything that we've talked about. So this whole thing, that's my diameter. Maybe I should not do that. That's right, diameter. Diameter. Okay, and then this is our secant line. Okay, and then we need to find what a tangent is. A tangent is a line that intersects in one point of a circle. Okay, we're dealing with something with a line. We need to find something with an arrow. That's obvious, right? And it intersects at exactly 1 point. It's obvious because this one is that line we were talking about, and it intersects in exactly 1 point. And you can't see it, but it's right there. So that means that is our tangent. This is our tangent. And then we fill in the blank. We say that that is line G. Cool. What else? An arc of a circle is the portion of the circle between 2 given points. Okay, here's an example. Here. This is what you call an arc, because it is a portion, or like a crust of the circle, from one point to another point. Here you go. That is the crust, and I will say see picture with red highlight. Okay? Now, let's move on. We're going to be talking about central angles and arc measures. Okay? So, what is the definition of central angle? Now, let's say if I have a point on the center of the circle, and I'm going to draw one radius, and I'm going to draw another radius. Take a look at this closely. What I just did was I formed an angle. Okay? So let's say that this angle, let's call this AB, and I'm going to say that this is 95 degrees. So what I have here is that I have the measure angle AB is 95 degrees. Okay? Now, let's say that I I want to show that I have another angle. And we say that this is 60 degrees. Okay? So, take a look at this. Take a look at this over here. It says the sum of all central angles is 360 degrees. Now, here's our central angle because it is joined with a point on the center, and here is our angle that I'm highlighting. Let me just, okay, there we go. So if I highlight this, that is a central angle because of this point. Now, the sum of all central angles is 360 degrees. If I were to ask you what this angle is, you're going to add 95 plus 65, and you're going to subtract that from 360. So what is this? You do 360 degrees minus 95 degrees minus 60 degrees, and that is the answer to this little question mark. Okay? Great. Now, we need to talk about arc measures. Now, the arc measure is always going to be in degrees. So let's say that I am looking for this arc measure. Okay, your arc measure is going to be in degrees. If I'm trying to look for this, well, what does it say? It says to find the measure of an arc, if we know the measure of the central angle, then the measure of the arc is the value of the measure of the central angle. So if this is 95, then my arc measure, let's say AB, is also 95. So this is 95 degrees, and I'm going to write it as follows. The measure arc of AB, and then this little curvy arc, or whatever you want to call it, that is also 95 degrees. Okay? Wonderful. Now let's do a problem that's from IXL. And then, so this is, this is worded by IXL. I included this just to throw it out there for fun. Okay, so it says, what is the measure angle of FDG? Where's FDG, right? So this is talking about central angles. So this over here, this is what we're looking for. What is this? What is the measure angle FDG? Or what is this in particular? Okay, so let's try to figure it out. Now, remember that the sum of all central angles is 360 degrees. If this is 80 and this is 130 and I'm going to make a 360, right? I can just do 360. Let's do 360 degrees minus 130 degrees. Got it from here. Minus 80 degrees. And I also got that from there. So what is that going to give me? That is going to give me 150 degrees. Okay? So this measure angle is 150 degrees. Or you can say that the measure arc FDG, the measure arc, let's see where I can put that. The measure arc FDG is 150 degrees. Cool. What else do we have to do? What is the measure arc GE? So, this is what we're looking at. This is what we're trying to figure out. Now, remember, to find the measure of an arc, if we know the measure of a central angle, right, then the measure of the arc is the value of the measure of the central angle. So if this is 80 degrees, then my measure arc GE is also 80 degrees. So that means my measure arc is 80 degrees. Okay? So that only works if you have a central angle. If you have a central angle and you're trying to find the measure arc GE, this is equal to this. Alrighty. Let us move on to another example. It says, what is the measure arc TU? Okay, so we have the central angles because of the point on the center and some radii here and there, right? The sum of all central angles is 360 degrees. So this 140 degrees, my measure arc is 140 degrees. This is also 140 degrees. If this measure arc SU is 110, then my central angle is 110. So that means that, okay, we have to have that all have to equal to 360 degrees, right? So what is the measure arc TU? Where's TU? TU is right here. And we say that the sum of all central angles is 360. So let's just write that down just to show 100. This is 100. This is 110. So that means that I need to do 360 minus 140 degrees minus 110 degrees. What is that going to give me? 110 degrees. And that means my measure arc TU is 110 degrees. So this is 110 degrees, and this is also 110 degrees. 140 plus 110 plus 110 is 360, so we know that that works. Okay? Nice. Let's talk about the introduction to circumference. And remember I said that at the beginning, the circumference is the perimeter of the circle. And in order to find the circumference of the circle, there are these two formulas, and they are pretty much the same. You can use one or the other. It doesn't matter. The circumference is 2 pi r, where r is the radius. Or you can say the circumference is equal to pi d, where d is the diameter. Okay, remember what the diameter looks like this. Right? It's our chord. Or suppose that you have a center. There's one radius here, and there's one radius here. A radius plus a radius is the diameter. Okay? Or 2 times the radius, if that's what you prefer. Nice. Okay. I wrote some stuff here just to, show some things, but I should delete that. Let's get rid of that. Let's get rid of this. Okay. Now we're going to be talking about arc length. Okay? Now, before we talked about arc measure. Arc measure is not the same definition as arc length. Arc measure deals with degrees, right? And, think about, like, when we're talking about degrees, like, oh, I did a 360, I'm sorry, you did a 360 or, I don't know, a 180, yeah, something like that, right? But arc length deals with feet or inches, or some distance from one point to another, right? And let me show you the difference between the two definitions. So, starting with arc measure, suppose that we have a smaller pizza and a bigger pizza. If I draw a point on the center of the smaller pizza and a point on the center of the bigger pizza, and I'm going to draw my central angle, I'm drawing my radii, then that means that, let's say that this is 95 degrees, and this is also 95 degrees, okay? It's a circle, all right? Circle is 360 degrees. If my central angle is 95, and my central angle is 95 for the bigger pizza, then that means my measure arc is also 95 degrees. And this is also 95 degrees as well, okay? So that means that we're dealing with degrees. If we're dealing with degrees, then we're going to be dealing with arc measure, okay? But for the arc length, which is a totally different story, because we have a smaller pizza and a bigger pizza, obviously you're going to have a smaller crust for the smaller pizza. The crust is smaller than the bigger pizza, right? Because we're talking about distance from one point to another. I don't know how long the bigger pizza is. This is probably like, I don't know. It's something in units, but it's not in degrees. If you hold up a smaller pizza, if you hold up one small pizza and one big pizza, of course this crust is smaller than this crust. Okay, and that's why I'm making a point about arc length. Cool. Now we need to talk about how we should calculate arc length. So the arc length is x over 360 degrees times 2 pi r. Okay? Now you're probably wondering, oh, what is x, Mr. N? What is x? Well, x is the arc measure. And r, this is our radius. And this formula is going to help us find the arc length. Okay? So let's do an example. The radius of a circle is 2 kilometers. What is the length of a 135-degree arc? Okay, now what I want to do is I'm going to write our given. This is the amount of work I want to see in general. Given, right? We're going to say that our x or our arc measure is 135 degrees. And again, why do we know that that's arc measure? Because it's dealing with degrees, right? What else do we need to put? R, right? That's another variable that we have to write. R is 2 kilometers. 2 kilometers. Now, since we have our given, we can just plug everything in. So I'm going to write my arc length. Arc length is equal to 135 degrees over 360 degrees times 2 pi 2. Okay, now 135 degrees divided by 360 degrees, that's going to be 0.375 times, so I have 2 times 2, so this is going to be 4. Don't forget the pi. So, this is supposed to be 375 degrees, sorry. So this is 0.375 times 4. 0.375 times 4 is 1.5. 1.5. And then drop the pi down, and you have 1.5 pi as your answer. Therefore, arc length is 1.5 pi. And yes, you can leave it in pi. This is your answer. Bye-bye.